This semester, our team partnered with the Clemson IEEE Robotics team to develop a robot for the SoutheastCon 2021 hardware competition. This is an annual competition between schools in the Southeast region. The challenge for this year's competition was loosely based on the Pac-Man arcade game. In this spin-off, a robot must navigate from the starting location to either corner A or corner C at the top left and right, where a power pellet block is located. It must also avoid two ghost blocks positioned randomly in the spaces marked G1 through G5. Once the robot secures the power pellet, it can go back and hit the ghost blocks to quote eat them and earn further points. Two purple blocks marked with a triangle and circle represented a power pellet and poison pellet. Similarly, two red blocks marked with a triangle and circle represented the two ghosts. After securing the pellet, the robot must eat the ghost with the shape matching the power pellet first.
There are four primary subsystems on our robot. The first is the startup subsystem, circled here in red. This consists of a rotary encoder and switches used to indicate the positions of the pellet and ghost blocks on the board, as well as a microphone and start button. This view also shows the arm with its adhesive plate that is attached to a servo motor and used to pick up the power pellet.
Mechanism wheels are used on our robot that theoretically allow for movement in any direction. Distance sensors are also mounted on each side of the robot to measure the distance between the robot and nearby walls. Once the robot reaches the approximate location of the power pellet, a computer vision system run by a Raspberry Pi 0W and a PiCam is used to pinpoint the pellet's precise location. Let's take a look at a full run in action.
The user will first use the encoder and switches to enter where the pallet and ghost blocks are. After this, there is a period when the proctor will announce which of the two purple pellet blocks is the power pellet by indicating whether the pellet is in corner A or C. Then, the user relays this information to the robot using audio communication.
The pellet is in corner A. At this point, the robot has all the information it needs to get to the power pellet's approximate location and navigates there while avoiding the ghosts.
To pinpoint the pellet's exact location, the robot uses a computer vision system to scan the area and isolate the purple block from the other blocks in the area to line up the robot. Once the robot is lined up, the arm is swung to pick up the power pellet.
Finally, the robot will move to hit the ghosts, ensuring that it first hits the ghost with the shape matching the power pellet.
We'd like to thank Jacob Thompson, Nolan Howard, and the Clemson IEEE Robotics team for allowing us to work with them this semester, and Matt Leckenbush for serving as our proctor for the competition. And lastly, the Clemson ECE department who provided funding for the project. And thank you for watching this video.